What are the properties of magnets? Just like how lodestone is discovered, magnets have the ability to attract materials. This is called attractive property. Not all materials can be attracted by magnets. Materials that are strongly attracted by magnets are called ferromagnetics. Examples are iron, cobalt, nickel, and steel. To make it easier to remember, let's use mnemonics. Icons: I for iron, CO for cobalt, N for nickel, and S for steel. So, icons are ferromagnetic. On the other hand, materials that are weakly attracted by magnets are called paramagnetics. This includes transition metals like aluminum, platinum, and uranium. And lastly, materials that are not attracted by magnets but instead repelled by it are called diamagnetics. Metals like copper, gold, and mostly human. All substances, in fact, have inherent diamagnetism. Now, let's move to the second property. If you suspend a bar magnet by a thread, one end of it will always point in one direction. This is called directive property. The end that always points at the north part of the earth is called north-seeking pole, or simply N-pole or North Pole, while the opposite end is therefore south-seeking pole or South Pole. This is because the Earth itself is a giant magnet. However, there is a distinction between the Earth's geographic and magnetic north. Geographic north, or also called as true north, is the direction towards the fixed point called the North Pole. Magnetic north is a wandering point on the Earth's northern hemisphere. The direction in which a north pole of a magnet points on the Earth's magnetic north changes from place to place on Earth. The angle between geographic north and the Earth's magnetic north is called declination. So, the declination in Indonesia is different from any part of the Earth. Aside from that, Earth's magnetic poles are constantly shifting. 100 years ago, the magnetic North Pole was located in northern Canada, over 200 kilometers south of the geographic North Pole, and it's been moving consistently since then, currently sitting in the middle of Arctic Ocean 450 kilometers south of the geographic North Pole, and drifting about 55 kilometers closer to Russia each year. What's more, the magnetic South Pole is not on exact opposite side of the Earth from the magnetic North Pole. How fascinating, right? And not just that. Since the North Pole of the bar magnet is pointing on the magnetic north of the Earth, it only means that the Earth's magnetic north is actually south. That is due to the third property, which we will discuss on our next video.